let's look at what we're assigned to do this week. We're assigned to do a lesson that deals with special right triangles. Now, we've talked about 45, 45, 90 triangles before. We've pointed out that this side and this side are the same length because it's an isosceles triangle, and these two angles are the same, so these two sides are the same. And when we use the Pythagorean theorem, we find that this side is the square root of 2 times a. And this one is just the side length a, and this one's the side length a. So it's just this length, and then multiply it times the square root of 2, and that's what that length is over there for the hypotenuse. How does that affect trigonometry? Well, what we're looking at is we can find the sine of a 45-degree angle just by knowing these ratios and nothing else. Okay? I don't have to know anything about the triangle at all except for that ratio. Why? Well, the sine of the 45-degree angle is the same as all the sines. It's the opposite over the hypotenuse, right? So when we take the opposite side of either one of these 45-degree angles, the opposite side is that length, s. And then we take the hypotenuse is that length, square root of 2 over s. Now, there's a thing in mathematics that we call rationalizing the denominator. Why? Because we don't like having the square root in the denominator down here. So what we're going to do is we're going to multiply times the square root of 2 over square root of 2. Why? Because the square root of 2 times the square root of 2 gives me the number 2. And then I have the square root of 2 over 2. What happened to the side length there? Well, they canceled out. And they are no longer a bother. So we know that the sine of this angle is the square root of 2 divided by 2. That's pretty interesting, Mr. Greene. Try it on a 40 cosine here. Well, that's the adjacent over the hypotenuse, and that's going to be, darn, it works out to be the exact same thing, doesn't it? How about the tangent? Well, the tangent is, the tangent of an angle here, like this one here, would be the opposite, which is s, divided by the adjacent, which is s. So I've got s divided by s, and that's equal to 1. So, geez, we know those things really easily. We've got the sine of the 45-degree angle, the cosine of the 45-degree angle, and the tangent of a 45-degree angle. Seems pretty simple there. There's got to be something tricky about this, right? Well, when we go to look at a 30, 60, 90 triangle, it becomes a little bit more difficult. Remember, because the one opposite the 30 degree, that was the shortest side, and that was s. And then the hypotenuse, that was the longest side, and that was 2s. And then the other side, using the Pythagorean theorem, you can find it to be the square root of 3 times s. Can we do the same thing with this one? Can we actually find the sine of a 30-degree angle? Well, the sine of a 30-degree angle is the opposite divided by the hypotenuse. That means s divided by 2s, which is 1/2. The cosine of a 30-degree angle would be the square root of 3 over s divided by 2s. That'd be the square root of 3 over 2. Okay? How about the tangent? Well, that's going to be s divided by 3 over the square root, 3 times the square root of s. Once again, we're going to rationalize this denominator by multiplying it square root of 3 over square root of 3, and I'll have a 3 on the denominator and a square root of 3 on the numerator. So, not knowing any lengths at all, I could still find the tangent, the cosine, and the sine of a 30, 60, 90 triangle and of a 45, 45, 90 triangle. Those are interesting little aspects. Wait a second, what's this? We were dealing with a 30-degree angle there. Can we do the 60-degree angle? Let's see. 60-degree angle is going to be done the same way. So let's see here. Here's my 60-degree angle down here. I'm doing it with you. And we're going to find the sine of it. That's the opposite. That's this number divided by the hypotenuse. That's this number. The s's are going to cancel out, and I'm going to have the square root of 3 divided by 2. Wait a second, Mr. Greene. That's what the cosine of a 30-degree angle was, and you're telling me that the sine of a 60-degree angle is the same thing? Yep, that's the way it works out. You know what? In most of them, they're just opposite each other like that, and you can find them very easily. How about a cosine of a 60-degree angle? Cosine, well, that is the adjacent, which is s, divided by 2s. That means it's going to be 1/2. How about the tangent? Well, the tangent of a 60-degree angle is the opposite, square root of 3 divided by s, or square root of 3. Well, that one didn't work out to be quite the opposite, did it? Because this one was square root of 3 divided by 3, and this one is the square root of 3. Hopefully you saw where I was pointing there. Try that again. Over here on the 30-degree angle, the tangent of a 30-degree angle is the square root of 3 divided by 3, but the tangent of a 60-degree angle is just the square root of 3. But you notice the cosine of a 60-degree angle is 1/2, and the sine of a 60-degree angle is 1/2. And the cosine of a 30-degree angle is the square root of 3 over 2. And the sine of a 60-degree angle is the square root of 3 over 2. So you can use those facts. Those things help you. How do they help you? Well, if we had a problem that said find the height of this tree, we could say, well, if I measure 10 feet away from the tree and make it a 60-degree angle, that means this is a 30-degree angle up here. What's this length right here? Well, I know that. That's what you do with the 30, 60, 90 triangle. That's going to be the square root of 3 times 10, well, square root of 3 over 2 times 10. Right? So that's the short length. And I'm going to multiply it times the square root of 3, the sine of the 60-degree angle, the square root of 3 over 2, and it turns out to be 5 times the square root of 3, or approximately 8.7 feet. Interesting approach, Mr. Greene. I can tell you right now, you're going to see problems like this, okay? Where are you going to see a problem like this? You're going to see problems like this in the quiz. You're going to see problems like this on the part 1. You're going to see problems like this on the part 2. So make certain you know how to work these type of problems, okay? Now, on Wednesday, you're going to be taking up this law of sines. Wow, that looks difficult, Mr. Greene. Not difficult at all. The law, when we're talking about the sine, the cosine, and the tangent, we've been talking about 90-degree angles. We've been talking about right triangles. But I want you to know that they found out that the sine was not necessarily restricted to 90-degree angles. Here's what they found. They said that if you took the sine of this angle right down here, A, and divided it by its opposite side, A, and then took the sine of this angle over here, B, and divided it by its opposite side, B, and then took the sine of this angle up here, C, and divided it by its opposite side, C, they were going to equal the exact same thing. How does that help us? It helps us because we can take problems like this. You can take a problem like this, okay? If I'm given that this is 80 degrees up here, and this B is not given to me, but this is a 40 degrees, and this is 16, I can set up a thing that says the sine of 40 divided by 16 will be equal to the sine of 80 divided by B. And we can find B then. We cross multiply, divide. You know how to solve ratios like this, or proportions like this. You cross multiply, you divide by whatever you need to, and you would wind up finding what B is. It's a real easy thing to do, okay? Same things over here. If I have 75 here and 25 here, I can say the sine of 75 divided by 25 will be equal to, well, we don't know what this one is up here, this S, so we can say the sine of S divided by 23. Cross multiply, divide, and you're going to have sine of S is equal to some value. And that's where you use the sine inverse of whatever value you get. Okay? What would that value be? It'd be sine 75 times 25 divided by, or 23 divided by 25. Okay? Sine of 75 times 23 divided by 25. And you take the inverse sine of that, and it'll tell you what this angle measurement is up here. So I can use it to either find angle measurements, or I could use it to find side measurements. Mr. Greene, I'm confused by your slide. Why are you telling us this stuff about AAS and SSA and ASA? Those are the three-letter acronyms that go with triangle congruence, right? Yes, they are the three-letter acronyms that go with triangle congruence. And what they're trying to point out to you is that we can find a triangle that is congruent to this one, okay? That is congruent by angle, angle, side. What do we give it? Angle, angle, and a side, right? And if we know that triangle that is congruent to it, we might know what B is. But the way you solve this is by using the law of sides. You set up those proportions and you solve them, okay? That's exactly what you've got to do to solve these type of problems. Set them up as a proportion and solve them. Now there's a little bit more difficult one called the law of cosines that we're going to get to in just a second. But I want to show you how one of these problems has worked for us here, okay? First of all, we're trying to find what side B is. Here's B right here, okay? Here's an 82-degree angle that's opposite it. So what am I going to do? I'm going to say the sine of 82 divided by B is going to be equal to the sine of 54 divided by A by 14. 54 and 14, they're opposite each other. 82 and B, they're opposite each other. What am I going to do? I'm going to cross multiply. B times the sine of 54, 14 times the sine of 82. And then I'm going to divide that sine of 54. And I'm going to get this before I touch the calculator at all. Why? Because by getting this, I can then key that all into the calculator at one time, and it'll tell me that that side over here is approximately 17 inches long. How does that work? Wow, that's an interesting one. Okay, let's look at the law of code. Wait a second, one more problem like this. I've got an angle. I've got two sides here, right? Well, what can I do? I can set up the law of sine still, because I've got two sides. I bet you I'm trying to find angle E up here. That's the one I'm missing. So what am I going to say? I'm going to say the sine of 65 divided by 13 is going to be sine of E divided by 9. I'm going to multiply this one over here times 9. Why am I just multiplying it times 9? Because it's easy to cross multiply and then divide by 13, but it's still just as easy to just multiply it by 9 and get there. So I find that the sine of E is approximately equal to that. Well, if I take the inverse sine of all of this mess, I will find that the angle E is 39 degrees. Now, I'm going to really recommend you guys, when you're doing these things, before you key them in on a calculator, get to this point right here first, okay? Because if you can get to that point right there, then it's easy to just key it all into the calculator at one time and get the answer, okay? If you start keying it into the calculator before that time, you're going to get messed up. So always make certain that you're solving it down to that point right there before you key it into the calculator, okay? So let's look at this one here. It says, during a soccer game, the positions of 3 players form a triangle on the field. Find the distance between player D, that's this player right here, and player F, this one over here. Well, we're trying to find this distance right over here, D. So what am I going to do? I'm going to set up my law of sines here. Wait a second. I don't have all the things I need. I'm going to have to find this angle over here first. Oh, you know what? I do know that angle, don't I? It's 180 minus the sum of 124 and 30, 154. So what is that angle? 6. That's here. 7 minus 2 is 7 minus 5 is a 2. 26 degrees. That's a 26-degree angle right there. So let me set up my law of sines now. It'll be the sine of 26 degrees divided by 12 will be equal to the sine of 30 degrees divided by that distance that we're looking for. Ah, that was simple, Mr. Greene. That just was a little bit tricky, wasn't it? Okay, see, they had to find that angle there first. And then what did they do? They set it up just like I said, sine of 26 divided by 12, sine of 30 divided by side DF. So what did they do? They took the sine of 30, divided it by the sine of 26, multiplied times 12, and that's going to be equal to df, right? It's approximately 14 yards. Okay? Now I don't want you to get confused by this cross multiplying. All I'm doing here is I've multiplied this one times this one, multiplied this one times this one, and then divided the df out. Okay? Or divided by the sine of 26. This is easy to type in a calculator. You press sine, you press 30, you press enter, you hit divide. You press sine, you press 26, you hit equal. It gives you a value. You hit times, you hit 12, and it gives you the number 14. It really is easy to do when you get to the calculator. Okay? Now, law of cosines. Oh my gosh, Mr. Greene, look at that. That looks impossible to do. You know what? It's really easy to memorize because you already know the Pythagorean theorem, don't you? Look at this. A squared plus B squared equals C squared. A squared, B squared, C squared. But since we're not dealing with right triangles, that's not going to be true, is it? So what they do is they subtract off 2 times B and the cosine of angle A. BC times the cosine of angle A. So what am I doing? I'm taking any one side here, this one here. If I was taking this side here, that's going to be equal to this side squared plus this side squared minus 2 times this side and this side multiplied together times the cosine of this angle. Does it really work? Yes. And since we're not dealing with the right triangle, I can actually use any one of them as A, B, and C, and it works. Okay? So if you only memorize one of them, that's all you have to do because it works the same way for every one of them. Okay? You see what I'm looking at. This side is the one I'm trying to find. I'm using the other 2 sides that I know, aren't I? I'm taking B squared plus C squared, and then I'm going to say 2 times BC and the cosine of that angle. And that's going to be subtracted out every time, and it works very simply. Okay? Let's look at this one here. If I'm trying to find angle C right there, how am I going to do this? I'm going to say 8 squared plus 14.5 squared. Where did I get those from? Those were the 2 sides that I didn't know. I'm going to subtract off from that 2 times 8 times 14.5 times the cosine of 74 degrees. And that's going to be equal to C squared, this side over here. Let's set this one up over here. I've got all 3 sides here. What am I going to do? Well, you know what? What if we were trying to find any one of these angles? Pick an angle. Well, let's say pick B. I didn't try B before. So let's see here. Well, the side opposite that one is this one over here. So that's going to be 38 squared. 38 squared is going to be equal to 46 squared plus 15 squared minus, what's it going to be minus? It's going to be minus 2 times 46 times 15 cosine angle B. I've got numbers everywhere, right? I can subtract, I can divide, and I'll find that cosine B is equal to a number. I can take the inverse cosine of whatever number I get, and that will be the angle. That's the way you work these type of problems. They're really, really simple to do. You just have to look at them for a while, okay? Let's look at one here. In this one, we're trying to find A, that side over there that we don't know. So what am I going to say? I'm going to say that A squared is equal to 18 squared plus 12 squared minus 2 times 12 times 18 times the cosine of 35. Plugging these into the calculator. Those are all numbers, aren't they? Well, 12 squared plus 18 squared, that's 468. 2 times 12 times 18, that's 432 times the cosine of 35. When I take the cosine of 35 and subtract that from 468, I get 114.1263169. I take the square root of that, and I get, almost 11. 11 squared is 121, so it's just almost 11, isn't it? That didn't seem that difficult to do. Let's try another one. We're given all three sides of a triangle. How would we solve this one? We're trying to find angle T up here at the top. So I'm going to say 20 squared is going to be equal to 14 squared plus 10 squared. See, 20 squared, 14 squared, 10 squared, minus 2 times 10 times 14 times the cosine of t. So let's do some solving here. 400, 10 squared is 100, 14 squared is 196. Add those together, I get 296. 400 equals 296 minus 280 cosine t. Well, that's 2 times 14. That's 140 times 2 is 280 cosine t. That seemed pretty easy to do. I'm going to subtract the 296 from the 400, and I get negative. Yeah. Right. I subtracted the 400 from this and added the cosine, 280 cosine t to the other side. Okay? I got a negative 104. I divide by 280. That gives me cosine t. Now, the negative sign shouldn't throw you off. Yes, cosines can be negative. So what you need to do is to put it in your calculator as the inverse cosine with that little negative 1 on it of negative 104 divided by 280. And it comes out to be 112 degrees. Cool? I think these problems are really quite cool. I really do like them. Now, here's another practical problem. So it's during a hockey game. Player A passes the puck 18 feet to player B, who then passes the puck 12 feet to player C. The angle formed by the puck is 102 degrees. They say solve the triangle formed by the three players. So what are we trying to do? We're trying to find how far AC is over here. Well, AC is going to be AC squared, or B squared, is going to be equal to 12 squared plus 18 squared minus 2 times 12 times 18 cosine 102. 12 squared, 18 squared, minus 2 times 12 times 18 cosine 102. Can I work those things out? I get 24 feet right there. Cool. I like that problem. Okay? Now, we know that B is 24 feet. We can use the law of sines to say that the sine of A, this angle over here, sorry, N, thank you, angle A, this one right down here, divided by 12 will be equal to the sine of 102 divided by 24. Cross multiplying and dividing, I find that angle A is 29 degrees. Now, I could do that law of sines again, but you know what? 102 plus 29, that's 131 degrees. I subtract that from 180, and I get 49 degrees. So this is the 49 degree. You know, we found every measurement in that triangle. And that's what they mean by solve the triangle. When they say solve the triangle, they're wanting you to find all the measurements in that triangle. Okay? And we just did it with a very practical problem.